Energy Switch is the popular point-counterpoint show where two leading experts with different perspectives discuss the most pressing energy and climate issues in the news today. Next on Energy Switch, how can we dispose of and recycle solar panels?
Funding for Energy Switch was provided in part by the University of Texas at Austin and by EarthX.
Millions of solar panels are reaching their end of life, and we don't have a plan to handle that. Many are going to landfills or interim storage because recycling is expensive and difficult, and there's only one dedicated facility in the world. We're not sure who will pay for recycling or disposal and how that might impact the cost of solar electricity. We'll talk about this and more with my expert guests. Serasu Duran is an assistant professor at the Business and Operations School of the University of Calgary. She was trained at Northwestern University and in her native Turkey.
Without special processes, we cannot really get those materials out. I mean, solar is growing, but that could change if the technology stops being cost competitive, and everything we talk about here about the end of life can have an impact on that.
With her, Garvin Heath is a researcher at the U.S. National Renewable Energy Lab. He's been conducting life cycle assessments and sustainability analyses of energy systems for nearly 30 years.
Solar panels are designed to last for 3 decades in any environment on Earth. And they're supposed to operate in all those conditions and function. And when you build something like that, it's probably going to be hard to unbuild it.
I'm Scott Tinker, and I'm an energy scientist. On this episode of Energy Switch, solar panel recycling. So why do our viewers care about the solar panel disposal and recycling?
Solar panel installations have grown a lot, and they are projected to grow. So following that momentum of growth, there will be the trash of solar or waste of solar. So we need to get prepared now so that we don't end up with that trash in our hands without having a plan in place.
I mean, I agree with Serasu. They're designed with warranties of 25 to 30 years. The National Renewable Energy Laboratory, where I work, has estimated that the average lifetime, based on hundreds of thousands of modules that we've measured, is actually probably 32 years, so beyond the warranted performance. And yet, even after decades of use, there will come a time when it's end of at least that initial life.
Yeah.
What we hope is that we will develop a circular economy approach so that all of the embodied energy and embodied carbon, water, and other things that went into manufacturing them gets used for as long time as possible and amortized over that whole time.
Sure. Well, let's dive in a little bit. Real big picture. Solar panels. How many are there in the world? Any guesses?
I believe the world has now reached over 1 terawatts of installations globally. Half of it has been installed in the past 2 years. So this is an exponential growth. And maybe by 2030, we expect 1 terawatt to be built annually.
For people who don't speak terawatts.
Yes.
Like a typical rooftop solar panel.
Well, yeah. Terawatts is hard to conceptualize. So I guess a typical panel is about maybe 300, 400 watts. Converting that number, I mean, 1 megawatt will conservatively put you around maybe 2,000 panels, and then scaling from that, a terawatt is like 2 billion panels we have today. Yeah.
Globally?
Globally, yes.
Solar could become one of the largest industries in the world if it gets to that scale of manufacturing. It'd be equivalent or greater than the aluminum industry in the world.
Yeah. And you mentioned 32-year average lifetime in the U.S. Is that lifespan growing? Is that technology helping that last longer?
Yes. So the reliability has to do both with preventing failures or understanding the modes of failure and then trying to help manufacturers prevent them, as well as degradation. So the performance is declining over time. And so both of those metrics have improved over time as we've gained knowledge about why is it happening and what we can do to manufacturing or operations and maintenance start to limit that.
So we often in energy talk about capacity. So the capacity of something is X. As efficiency goes down, then that capacity goes down, and at some point it makes more sense to replace it because you're just losing efficiency. Is that why we replace these, or why not just let them play out till they're just dribbling along here?
Solar panels not only are getting better, they're also getting cheaper. So I think it was the Department of Energy that estimates the cost of solar reduces about 10% every year. So essentially every year you get cheaper and better models, and this is a money-generating product. So it makes sometimes more sense economically to just, pay that little bit extra, which is quite affordable now, install a new system and make more money the next 15, 20 years.
Okay. You agree?
We don't have evidence of how much this is happening. It's theoretical to say that as soon as I could, after amortizing my capital costs, earn a penny more on something new by replacing this old thing, that I would do that. That would be economic rationality.
Yeah.
But we know the humans don't act that way.
Right.
So we're going to be slower in that behavior of economic sort of changing out of these modules than that economic rationality might predict.
It probably varies by socioeconomic class, and I think you're saying that.
And you have values and personal motivations.
So
I do have a little bit of a disagreement there.
Yeah.
It's not only residential customers that have solar, right? When you think about commercial installations, utility scale installations, companies making these decisions, economic rationality has a bigger picture in it.
a lot of
We
variables
see
in there.
differences also in different world regions. So where there's more land pressure, you might have more value to the land that you've already occupied with solar modules. And that might motivate you to then say, I really should try to maximize what I'm getting out of this land. Europe would be a good case for this.
Yeah.
In the US, lots of land that we can use for new facilities, new solar power plants, less pressure on the existing ones to try to maximize that land acreage.
Yeah, very good point. At that point, it probably makes more sense to, add newer panels to what's existing there when you have the land available for it.
So we got a couple billion panels out there, and we probably haven't really had to start replacing most of them yet. Are we about to see a big sort of, a lot of panels wearing out moment?
Early installations started picking up after the turn of the millennium, so maybe early 2000s.
Right.
So the first waves are starting to come out now.
Okay.
So we will have that exponential turn of waste volumes in 5-10 years, even if there were no early failures.
Right. So what happens now to solar panels that get decommissioned?
So you take out your solar panels, and panels themselves could go to existing glass or electronic waste recycling facilities today, which is not that much.
Okay.
And the rest would pretty much go to landfills unless you find opportunities to maybe refurbish and reuse them in other circumstances.
Yeah.
Talking about the crystalline silicon, which is the most common one, is you have this aluminum frame holding the glass, the solar cells, silicon semiconductors, and the back sheet, which is polymer, all together, which are all glued together. So it's really hard to take those apart again and deconstruct and separate it in a clear way and get to those materials in their pure form. So you cannot really purify or separate the materials, which is even harder with the solar cells. That silicon layer, which is almost sort of like unbaking a cake. So due to that, I mean, it's a bit extreme analogy, but
it helps
without really special processes that electrical, chemical, we cannot really get those materials out, and with mechanical shredding, it's mostly just shredding them all together.
I gotcha. More thoughts on that? Or?
Well, it comes from how solar panels are designed to last for 3 decades in any environment on Earth.
Yeah.
And they're supposed to operate in all those conditions and function. And when you build something like that, it's probably going to be hard to unbuild it.
Right.
There could be changes to the manufacturing process, keeping in mind performance, keeping in mind economics, that really are the 2 paramount concerns. And there are some thoughts on how to do that, but it's been really challenging. So maybe it's useful to talk about what's in a solar panel.
Yeah.
So by mass fraction, the largest mass component of a solar panel is glass.
Yeah.
And that's just assuming we have 1 layer of glass. Now there's what's called bifacial, which has 2 layers of glass.
Right.
Almost always there's going to be a frame. That's the 2nd largest mass component. For crystalline silicon module, it's silicon is now the 3rd.
Okay.
Now they've been getting thinner and thinner and thinner, these wafers of silicon, so there's less silicon. And then you have some constituent metals. You have some copper, you have some silver, you might have some other metals in there.
Any of them toxic?
So I lead an international energy agency group who focus on sustainability issues of photovoltaics. In that capacity, we've completed 3 human health risk assessments. One is PVs exposed to fire. The second we looked at was a PV module that's broken and left in the field. And the third way is by putting them in landfills, But in all those cases, we looked at the primary metal of concern for human health. It's going to be lead for crystalline silicon modules and cadmium for cadmium telluride modules. And in all those cases, the human health risk assessment from that showed that all three of those were found to have human health risks that were not above, not triggering any extraordinary concern.
Is this some kind of an averaging thing, Garvin? Or?
No, it's the worst case. So the worst possible assumptions about exposure is
Interesting.
what we're taking into account in doing that.
Has the
1,000 times
EPA
below.
caught up with the fact we don't really count them yet? You know, I mean, if you were on the EPA, would you be going, you know, we need to get out in front of this because we're going to have $2 billion a year, not...
I certainly can't speak for the EPA.
No, I know what I mean.
But there have been petitions to draw EPA's attention to this, and that I believe that they're responding to those petitions.
Okay.
The EPA has sent experts to various forums, so they're engaging in discussion on this.
Yeah.
And it
That's
fits
good.
into their Resource Conservation and Recovery Act, RCRA, framework of dividing between hazardous and non-hazardous wastes.
Right. What are the main strategies for recycling? Are there different approaches to it?
Broadly, there are 4 approaches. Mechanical means that you're going to try to abrade a surface and scrape it away. Thermal means that you're going to heat that. You're going to heat this, and for instance, with the layers that are stuck together with encapsulants or adhesives, they would melt those, and then you could separate them. Chemicals would be an alternative to that thermal process of trying to reduce that the bonding between the layers of materials. And then finally, you have optical, which you can think of as lasers. So you could do that same process with lasers. Certain of these processes are going to have certain environmental impacts.
Right.
You know, chemical processes are going to produce an effluent of wastewater. A thermal process, you need to be concerned about the air pollutants that are emitted. Mechanical ones, you need to control the dust, you know, et cetera. So all of these have challenges.
Do they blend them sometimes too? You get...
Absolutely, they're not singular sort of systems, one approach. Often they're sequential, sometimes they're even together. And we haven't consolidated on a single technology that's going to be the best approach to do that. There are researchers that are looking at lots of these. And of course, even after we do that work in the lab, we're going to have to bring it to try to scale and commercialize, and we're going to have more learning, and we're going to make more changes.
Sure. So what's the cost difference between sort of recycling and then landfill disposal?
Correct me if I'm wrong, I would probably put recycling at like $15 to $40 per module versus landfilling a few, like up to 5 at most.
Okay. Less money to dump it.
Yes.
Unless you can get the value out.
We need to work on finding as high value as possible end markets.
Right.
Solar, except for a couple of cases, does not have dedicated recycling systems.
Yeah.
If you are a metals recycler, you could accept a solar panel and you would be interested in the frame. And you might be interested in the wires and the cables.
Okay.
But your economics are not such that you can really handle all those
All that,
materials.
yeah.
Conversely, if you're a glass recycler, you're going to be interested in glass and you're going to be less interested in the metal. But they're emerging, and France has had the very first, and now it's actually a second generation of largest commercial scale dedicated, so focused PV recycling facilities in the world. Pretty exciting. But you know, one thing about price, I think the price is changing. And that's going to come, you know, a few different ways. Obviously from learning. Where can we use these things and how much can we sell them for to what next market? So for instance, we're putting 13N pure silicon into new solar panels right now. Purest substance on Earth that we're creating. It's a huge source of, you know, the embodied energy or the embodied carbon of a PV module. We would like to see people do something with that silicon that we can recover some of that value.
Right.
Can we put it back into the supply chain for creating that ultra pure silicon?
Right.
So maybe when we get it out, we have 99% pure or 99.9% pure or something. And so there's a big upside for the recyclers if they can get
to that.
maintain it as pure as possible and then return it back into some of that supply chain.
Sure. Who pays right now to recycle solar panels?
In the U.S., in the recent past, there were 2 models.
Right.
For crystalline silicon technology, there was not a manufacturer that had a recycling system. So it was the final owner who then was left with that choice of what to do, whether to pay for disposal in a landfill, whether to pay for recycling, whether to hold it. The other model that existed for a while, it doesn't exist any longer, is the largest manufacturer of cadmium telluride modules is a U.S. manufacturer, First Solar, and they originally had a plan that everybody paid up front, and that they guaranteed that they would take back those modules and that they would recycle them.
Yeah, interesting.
But First Solar actually now, because of competitiveness reasons, does not charge that upfront fee mandatorily. You can choose to do it, but you can also choose not to.
Gotcha.
When and to whom you charge these payments can have really important implications. So if there is a huge volume of waste and then manufacturers have to kind of pay for this amount of trash, which again, waste will grow, and as installations level off, technically you're gonna eating away of more and more of your revenue from these end-of-life costs. It could increase the levelized cost of solar, maybe double, triple, in a decade or so. So that would really be disadvantageous for competitiveness of solar technology. So a fair allocation of those end-of-life costs are really necessary.
I see.
I think that's maybe too pessimistic for what the costs will be. One thing we know from the solar industry is that they know how to innovate. The cost curves are tremendous and really one of the flagships that this technology is known for and this industry is known for. And so they're already starting to act in terms of trying to band together and support recycling initiatives. So there's a lot of opportunity within a window of like 15 years to make that go down to where there's parity. That's the goal.
Yeah, so I don't disagree, just like those estimates are the worst case estimates, right? So building it into the incentives for production, that would give, again, also more incentives for going for cheaper recycling technologies.
As the volume of panels increases, is that going to affect the disposal costs?
It depends. So there is both economies of scale and diseconomies of scale at play. If you're not prepared and don't have enough capacity, there will be an increase in costs. But on the other hand, if there is ample capacity, more volume means economies of scale, which can help reducing those costs.
Yeah, it's part of that cost, the energy that it takes.
Yeah, sure. And
got to get that from somewhere.
There are lots of different ways to propose about how to recycle a PV module. It's not consolidated. There's no cleared winner that's going to emerge globally or in the U.S. or anywhere. We need to get out there and start doing this at scale and start learning that way, commercializing. But there's a good possibility that we're going to have some solutions emerge that are going to reduce the cost side of the ledger. And again, we need to focus also on the revenue side of the ledger.
That scale helps.
One of the levers then to managing some of these costs is whether the module is determined to be hazardous or not. Panels right now are being judged based on a US EPA regulation that was not written to handle a module the way it's designed. And the sampling that you do of that module to determine whether it's hazardous or not might depend on whether you hit that sort of pure blue area or you hit the area that has that metal, strip going in it.
Yeah, interesting.
So panels have been found to either be hazardous or not. And it's hard to say exactly why that is at this point. But we also can eliminate certain of the target constituents that would determine whether it's hazardous. So for instance, a crystalline silicon module has lead in it. Where's the lead? The lead is in the lead tin solder that's interconnecting the cells, the silicon cells. And if you change it to not have lead in it, now you have a lead-free module that will not trip the hazardous waste regulations. And then you can improve your logistics and decrease your costs not only at the front end, but also at the recycling center.
Right. Makes sense.
Even targets like these material quotas or recycling volume targets, they do affect the cost in the end as well, because technically you first do the easiest ones, right? You cherry pick the ones that you can easily disassemble closer to the maybe recycling facility, and then as you grow trying to get more of that volume down, it's gonna get more and more expensive. Maybe you get panels that are a little bit disturbed, they're not in their perfect state, more contaminated, farther away regions that are harder to collect, so all of those will...
Right. Are there alternate or, kind of complementary strategies for recycling? What are some things that can complement recycling or even completely do instead of recycling?
First thing that comes to people's minds is reusing them, which sounds appealing because, I mean, you don't go through the processing cost. But reality, I think the economics of it doesn't work that well to support this. I mean, first of all, older panels are now less efficient and have less useful life left. And certain cases, they are not up to the current code of regulations. And complementary, it's not like really modular system, like you swap out an old panel, it can go on every type of inverter, every type of connector.
I get it.
And new panels are so cheap now, I mean, there's really not a market for these used panels. Like there's not much of a demand for them that's available. So.
Yeah, that cost curve on the panel construction kind of hurts in a sense, the recycling, because I'll just buy new ones, it's cheap.
Yeah.
So what's your plan? What's your action plan to handle solar panel reuse, recycling, disposal? Garvin, what would be your plan?
So my plan would try to make sure that we are doing all we can to minimize the amount of materials, choosing less toxic materials, improving the efficiency of the manufacturing process, operating and maintaining those as long as we can, building a reuse market that is really nascent today and has severe limitations, and then building the recycling systems that can be that backstop to prevent the loss of materials and all the value that we put into these technologies as they reach end of life.
Right. Serasu, same question. You get to call the shots. What's the action plan?
Yeah, I mean, it's not specifically a trash or a waste problem. It is a value recovery and resource efficiency problem. So, I mean, solar is growing, but that could change if the technology stops being cost competitive, and everything we talk about here about the end of life can have an impact on that. So circular economy is definitely a way to keep that cost competitiveness going. And the second component would be having regulation to ensure fair allocation of those costs.
What do you think the biggest potential impediment to that could be?
It's being too slow would be a bit of an impediment, I would say, as, you know, not having infrastructure or regulations could shift the scale against solar from a cost point of view.
Anything we didn't talk about, Garvin, that you want to make sure to mention?
Yeah, there's, I think, a lot of motivation across the different actors in the solar industry, from manufacturers to those that are involved in development and installation, as well as those who are buying the power coming off of those modules, using that power.
Right.
There's motivation across all of these actors to try to do the right thing. And even with lack of regulation, we already see that recycling is happening. It's not because it's cheaper, it's because people are wanting to do that, wanting to do the right thing. And there are initiatives happening where some of these organizations will start to get recognition for that. So there's one example of a voluntary eco-label that's already existing in the US through what's called the EPEAT system, where a module can be labeled, but includes that the module manufacturer would have a take-back and recycling program.
It's not fairy dust, it's actually measurable and trackable.
It's measurable and verifiable.
Good.
So
excellent.
in the marketplace, you can then trust that when you're specifying that or buying it, that you're getting something that has met all these criteria.
That's nice. That's a good idea. Well, thank you both. Scott Tinker, Energy Switch. Terrific. Really enjoyed the visit.
Thank you.
Great stuff. We heard there are now around 2 billion total solar panels installed globally, with projections for 2 billion more every year going forward. Most were installed recently and should last a few decades. However, as they wear out, reduced panel output may lead customers to replace them sooner with newer, cheaper models. Today, it's difficult to recycle old panels because they're built to be durable and contain many different materials, some of them toxic. So many panels are dumped into landfills or stored at the surface. It's possible to separate them into recyclable components, and France has now opened the world's first dedicated solar recycling facility. However, it's expensive, and there's no agreement on who should pay for disposal or recycling. All of this may increase the price of solar electricity. Future panels could be made more recyclable. However, ironically, if their cost continues to decline, recycling or reuse becomes less economically attractive.
Energy Switch is executive produced by Scott Tinker and produced and directed by Harry Lynch. Emily Hooks is the assistant producer and researcher. Editors are Ginny Patrick, Yusef Swachina, and Jackie Kunzler. Matt Aslanian does the sound. Energy Switch is produced by Arcos Films for the Switch Energy Alliance, with support from the University of Texas at Austin and EarthX.